Okay, so now 180 is done, and we have to close everything. Okay, the reason why we have to do that is generally the tool, nobody ever uses two different technologies in one day. Okay, because they come after a few years. If GPDK 180 came, for example, in 2010, GPDK 90 might have come in 2014 or something like that. So we know that there is a factor S, which is around 1.2, by which the size shrinks for every technology. So because of that, if some engineer is working in 180, he'll be working in 180 for a period of a few years at least, and then eventually when he gets the new set of libraries, he'll start working in, say, for 180 they might go on to 135 or something, and then he'll continue to work in 135. He will never suddenly work in the morning in 180 and afternoon in 90. So the tool is not designed to do that, but we can do that technically. But the only thing I recommend is you close the tool completely and come back to this terminal and start Virtuoso. And once we do that, we have to do a new step, file new library, because we don't have 90 nanometer library from before. We have to create a library like we did in the first step and attach it to GPDK090 and say OK. And it will say here design library successfully attached to technology library GPDK090. Then file new cell view and change this. This will be at the 180 nanometer, which is previous one. We don't want that. We cannot use that. It will create a huge problem. Okay, and you can call this again the same name FO4 you can give, and it will create. So now GPDK090. Okay, let's do a browse, for example, in GPDK90. Here the transistor that we use, there is no plain NMOS. It starts from NMOS 1V and goes all the way down to something else. The transistor that we use is the first one, okay, which is also called as NMOS 1V, and we will take the symbol. And here also we can remove this thing. The total width 120 nanometer is the minimum possible width, but we want to keep it at 200 nanometer for the NMOS transistor. And again we need 5 of those, so 1 2 3 4 5. And PMOS, again I'll do a browse. PMOS also similarly, there's no plain PMOS. It starts with PMOS 1V, so choose that one. And the total width this time, again you can put 120, which is the minimum possible allowed width, but we want to change it to PMOS transistor of size 2, so that will be 400 nanometer in GPDK90. I can place it in the same way above the NMOS transistors 1 2 3 4 and 5. And once this is done, you can place the sources, which is again from analog lib, VDC 1.8. okay, put that in the top and rotate it, and insert ground. Put one ground here, and put one ground here, and put one ground on this. Okay, then we'll make the connections. Fourth terminal, same rule, you connect it to the terminal with the arrow mark. So every transistor, take the fourth terminal and connect it to the terminal which has the arrow mark. So PMOS and NMOS both, you can follow the same rule. Okay, you don't have to remember anything else. Connect off the fourth terminals, then the bottom terminal connect all together and connect it to ground. Here also give this to here, and we connect it to the PMOS transistor. The same as last time, we need a V pulse for the input, and exactly the same parameters we'll give. 1.8 volts, period is 10 nano, delay we don't give, rise time 10p, fall time 10p, pulse with 5 nano. and give the and finally the output goes to the, sorry, we made the connections for this. Let's make the connections for the inverter first. Okay, and then do a check and save. One warning, so it's giving us a warning here. I think it's giving us a warning because the ground is too close. We just pull it a little bit farther apart and the warning disappears, and we should be able to simulate. So launch ADL, outputs, select on the design. This is the input signal, so that's this, and this is the, so everything gets selected. Okay, and then so here is a warning, it's giving me an error, and it's so sorry, forgot the analysis, choose transient 50N. Okay, and analysis has come here, separate, and the rest of the procedure is the same. Put the marker in the same 0.9 volts because our input is still 1.8. Okay, and for example leave the first few pulses, TP high to low, so 30.0234 minus 30.005, that will be TPHL, and TPLH 35.0348 minus 35.015. Okay, and that will be the propagation delay, fan out to 4 delay for GPDK090. And in terms of approximate numbers, if we do the calculations even here, GPDK090 should give you around 20 picoseconds FO4 delay. The other one should give you around 40 or 50 for the FO4 delay. Okay, thank you.